if we have two planes, they're either parallel to each other. So two planes. This is your first plane. And this is your second plane. Let me use a different color. This is your second plane. Okay, the normal vector for the first plane. And the normal vector for the second plane. So this is your n1. This is your n2. So once two planes are parallel to each other, it means that their normal vectors are parallel as well. Two planes are parallel. It means that their normal vectors are parallel to each other. So n1 is parallel to n2. So it means that the angle between these two is equal to 0. Theta is equal to 0. Cosine of theta is equal to 1. And this is equal to n1 times n2, the dot product, divided by the magnitude of n1 times the magnitude of n2. Or the dot product between n1 and n2 is equal to the multiplication of their magnitudes. n1 dot n2 is the magnitude of n1 times the magnitude of n2. You might have two planes that are intersecting. Well, suppose this is your plane with normal vector n1, and this is your second plane crossing this plane at some line or some point. Let me just have this one here. Very nice plane. So the normal vector for this plane, they're crossing each other at a line. So remember that when we had intersection between a line and a plane, the outcome was 1 point. I'm not talking about the case that the line is actually completely on the plane. If it's just crossing at 1. But if you have two planes crossing each other, then the outcome is a line. So two planes crossing each other at a line like this one here. Okay, now you can find the angle between these two planes by finding the angle between their normal vectors. Cosine of theta can be written as n1 dot n2 divided by the magnitude of n1 times the magnitude of n2. So by taking the inverse cosine of this number here, using your calculator, you can approximate the angle between these two planes. And let's go over one example together. To feel more comfortable finding the angle between these two vectors. Find the angle between these two vectors, these two planes, sorry. So here you have, let me see, x plus y plus z equals to 1. and the other one is given to us as x minus 2y plus 3z. This is equal to 1 as well. We want to find the angle between these two planes. We call that a plane with normal vector ax plus by plus zz equals to d. The normal vector has components a, b, and c. So the normal vector for the first plane N1 is 1, 1, 1. N2, the normal vector for the second plane, has components 1, minus 2, and 3. Well, we have the normal vectors. We have a nice formula to find the angle between these two vectors. Cosine theta can be written as the dot product between these two vectors. 1 times 1 minus 1 times 2 plus 1 times 3 divided by the magnitude of n1, 1 squared plus 1 squared plus 1 squared, and the magnitude of the second vector, 1 squared plus negative 2 squared plus 3 squared. So cosine theta is equal to, you have 1 minus 2 negative 1, you get 2 divided by square root of 3 times square root of 14. So cosine theta is equal to 2 divided by square root of 42. So theta is the inverse cosine of this number, 2 over square root of 42. Now you have to use a calculator to approximate this angle. Calculator approximation gives us roughly 72 degrees. This is the angle between the normal vectors and the angle between two planes. Okay, now I expect you to ask, hey, how do we find the equation of this line? Well, if a question asks you to find equation of the crossing line, to find the equation of this intersection, we need to find the cross product between N1 and N2. Then this line is in the direction of this vector. And last thing that we're going to talk about is the distance between a point and a plane. The distance between a point like P, x sub 0, or y sub 0, and z sub 0 from a plane ax plus by plus cz equals to d follows the formula d equals to absolute value of a x sub 0, b y sub 0, c z sub 0 minus d divided by square root of a squared plus b squared plus c squared.